History tells us the samurai were warriors, masters of the blade, bound by honor and the way of Bushido. But what if I told you that beneath their disciplined exteriors lay minds capable of engineering marvels that could have changed the world forever? What if, in an alternate timeline, the samurai didn't just perfect the art of war, but also pioneered the creation of mechanical warriors, robots, centuries before the industrial age? This is not the history you learned in school. This is the history that could have been. Welcome to a world where feudal Japan meets mechanical innovation, where honor codes are programmed into steel, and where the clang of katanas echoes alongside the whir of gears.
Our story begins in the year 1615, in an alternate timeline where the Battle of Osaka Castle concluded not with bloodshed, but with an unprecedented truce. The Tokugawa shogunate realized that endless war was draining the nation's resources, its brightest minds, and its future. Instead of suppressing the rival clans, Tokugawa Ieyasu proposed something radical: a challenge. Each clan would redirect their military ingenuity toward technological advancement. The clan that created the most impressive innovation within 10 years would earn the shogun's favor, land, and immortal honor. The samurai, whose entire existence revolved around combat, suddenly found themselves thrust into a new kind of battlefield, one of intellect, engineering, and imagination. The swords were not sheathed, but the minds were sharpened in entirely new ways.
The samurai were not starting from nothing. For centuries, Japanese artisans had been perfecting karakuri, mechanical puppets used in theater and religious ceremonies. These intricate devices, powered by weights, springs, and flowing water, could perform tea ceremonies, shoot arrows, and even write calligraphy. But they were entertainment, curiosities for festivals, and the amusement of nobility. The samurai saw something different. They saw potential, the foundation upon which something far greater could be built. Masters of karakuri craft were summoned from across the provinces. Clockmakers, temple engineers, even puppet masters were brought into the workshops. The samurai studied every gear, every spring, every mechanism, and then they asked the question that would change everything. What if we made them bigger, stronger? What if we gave them purpose beyond entertainment?
3 years into the challenge, the Takeda clan unveiled their first breakthrough. They called it Tekko, Iron Child. Standing 7 feet tall, constructed from iron plates, bamboo joints, and powered by an ingenious spring and weight system, it was unlike anything the world had seen. Tekko could walk. Not smoothly, not gracefully, but with a mechanical determination that sent shivers through everyone who witnessed it. Its movements were jerky, accompanied by the grinding of gears and the creak of metal, but it moved forward, step by step, without human intervention. For 10 minutes, it walked across the demonstration courtyard, then stopped, its energy exhausted. The assembled witnesses stood in stunned silence. Then, slowly, applause began. Not because Tekko was perfect, far from it, but because it proved something profound. The impossible was no longer impossible.
Teko's demonstration ignited a fire across Japan. What began as a scholarly challenge transformed into an obsession. The Date clan responded within months, unveiling Arashi, Storm, a robot designed not just to walk, but to carry loads. Using a revolutionary pulley system integrated into its torso, Arashi could transport up to 200 pounds of rice, lumber, or weapons. The Shimazu clan took a different approach entirely. They created Kage, Shadow, a smaller, more agile machine designed for reconnaissance. Standing only 4 feet tall, powered by a compact spring mechanism, Kage could navigate rough terrain and even climb rudimentary obstacles. Each clan guarded their secrets jealously. Workshops became fortresses. Engineers worked behind locked doors and sworn oaths of silence. But progress, inevitable progress, could not be contained. Every success inspired another. Every failure taught a lesson. And with each passing year, the machines grew more sophisticated, more capable, more alive. But not all samurai embraced this new direction. A faction led by the traditionalist Matsudaira clan argued passionately that the path of the warrior was being corrupted. "We are becoming craftsmen, not warriors," they protested. "Our hands should grip swords, not wrenches. What honor is there in hiding behind machines?" The debate raged in councils and tea-houses across the land. Yet the progressive clans had a compelling answer. "Is it not the ultimate expression of Bushido," they argued, "to protect our people without sacrificing their lives? These machines could build our cities, harvest our fields, and yes, defend our borders, while our warriors preserve their lives for when they are truly needed." The philosopher samurai Hayashi Razan wrote, "The greatest warrior is not the one who fights the most battles, but the one who prevents them. Through innovation, we create peace." Slowly, reluctantly, even the traditionalists began to see the wisdom in this vision. In 1625, 10 years into the challenge, the shogun called for a final demonstration. Each clan would present their greatest achievement, and the winner would be crowned. The Uesugi clan, known for their military prowess, had remained mysteriously quiet throughout the competition. While others demonstrated cargo carriers and scouts, the Uesugi had been working on something else entirely. They called it Musha, warrior. Standing 8 feet tall, armored in layered steel plates, powered by an advanced spring mechanism that could store energy for up to 30 minutes of continuous operation, Musha was built for one purpose: combat. Its arms could wield weapons, its frame could withstand strikes from swords and spears, and most remarkably, it could respond to simple commands through an innovative system of internal bells and levers. When Musha walked onto the demonstration field, the assembled crowd fell silent. This was no longer a curiosity or a tool. This was a warrior, mechanical yet formidable, and everyone present understood the world had just changed forever. The Usagi clan won the shogun's challenge, but the true victory belonged to innovation itself. Within a decade, mechanical assistance had become woven into the fabric of Japanese society. In the rice fields of Niigata, farming robots helped with harvest, their tireless mechanisms working alongside human farmers from dawn until dusk. In the ports of Osaka, cargo loading machines revolutionized trade, lifting burdens that would have required dozens of men. In the temples of Kyoto, karakuri-derived machines assisted monks with daily rituals, ringing bells, carrying offerings, even maintaining gardens with mechanical precision. But the most profound integration happened in the samurai households themselves. Wealthy clans commissioned personal mechanical retainers, smaller, more refined robots designed to serve tea, maintain armor, and guard estates. These iron retainers were status symbols, but also functional members of the household, treated with a respect that blurred the line between tool and being.
As robots became more common, a fascinating philosophical debate emerged. Shinto priests argued that machines, crafted with such care and devotion, could develop their own kami, spirits. After all, ancient trees and stones were believed to house spirits. Why not mechanisms that moved with purpose? Buddhist monks took a different view. They saw the robots as reflections of humanity's impermanence, reminders that all things, even seemingly immortal machines, would eventually break down and return to the elements. Some engineers began incorporating ritual into their craft. Before activating a new machine, they would hold ceremonies, blessing the robot and asking it to serve faithfully. When a machine could no longer be repaired, formal retirement ceremonies were held, its parts disassembled with reverence, its service honored. The most intriguing development was the concept of mechanical bushido, a code adapted for robots. Loyalty was programmed through design, honor through function, and duty through purpose. The line between the living and the mechanical became not a wall, but a spectrum.
But not all consequences of the mechanical age were positive. In the countryside, displaced workers who once earned their living through manual labor found themselves unemployed, their skills rendered obsolete by tireless machines. Resentment grew. In 1638, a group calling themselves the Flesh and Blood Brotherhood began sabotaging robots, breaking their mechanisms and leaving cryptic messages. Honor cannot be forged in iron. The shogunate was forced to act. Laws were passed requiring that for every robot employed, a human worker must be hired for supervisory or maintenance roles. Guilds were formed, training displaced workers in the new skills of robot maintenance and operation. The crisis forced society to confront a fundamental question: progress for whom? The answer, hard-won and imperfect, was that technology must serve humanity, not replace it. Robots were tools, powerful tools, but they required human wisdom to wield properly. This philosophy would shape the next century of development, ensuring that innovation and humanity walked forward together. In our timeline, the samurai never created robots. Feudal Japan gave way to modernization, and the warrior class gradually faded into history. But in this alternate world, something remarkable happened. The fusion of ancient warrior philosophy with mechanical innovation created a society unlike any other, one where honor was programmed into steel, where tradition empowered progress, and where humanity learned to walk alongside its creations as partners, not masters. The mechanical samurai may not have existed in our history, but their story raises profound questions that echo into our present. As we stand at the threshold of our own age of artificial intelligence and robotics, perhaps we have something to learn from this imagined past. How do we integrate technology without losing our humanity? How do we honor tradition while embracing innovation? And most importantly, how do we ensure that the tools we create serve all of humanity, not just a privileged few? The samurai of this alternate timeline found their answers through philosophy, adaptation, and unwavering commitment to human dignity. Perhaps we should do the same. Thank you for joining me on this journey through a history that never was, but perhaps could still teach us something about the future we're building. Until next time, keep wondering, what if?